Hi, today we are going to talk about the design of tools and equipments. Of course, people can perform several tasks on their own with their own hands without the use of tools or equipment, but the use of tool and equipment will help people do the task more easily. Of course, you can scoop sand with your hands to move it from one place to another, but using a shovel will make this task much easier. Also, if you want to take down a big tree, using an axe or a saw will make it much easier. So the tool helps people perform the task more easily, and sometimes the tool replaces the function of a damaged limb or other part of the body. So in this case, also handicapped people can perform different types of jobs and tasks. So ergonomists will be involved in designing uh, different tools and safety devices and personal protective equipment. Why? To ensure safe and effective operations. Tools extend the capabilities of humans because some tools give you much better grip or torque or impact or allow you to have better control over the task you're doing. And of course, it allows you to handle larger volumes of content at a time. You can, let's say, transfer much greater quantity by a certain equipment than by doing it on foot or by hand. So, in general, tools give new capabilities and more capabilities to the hand. So that's why designers are interested in knowing the measurements of a human hands. And because we know that human hands differ between people, between gender, whether it's a woman's hand or a man's hand, so we have different sizes. So this has to be taken into consideration when designing tools to be used by people of different hand sizes. So these designs accommodate hand sizes from the smallest woman to the largest man. Here are some of the measurements that you need to be aware of. We have the hand breadth. Okay, you see it is the distance between this edge of the finger to this edge without taking into consideration the joints here. And we have the hand length. It is the distance from the wrist till the tip of the finger, the middle finger. And we have the hand circumference. You see it is the circumference from the side to the side, and it rotates. It gives you the circumference of the hand. And here you can see that we have the sizes from the first percentile till the 99th. We have different measurements for men and women. Okay, for all these three important measurements that you need to be aware of. One of the major ergonomic concerns of a hand tool design is the weight of the tool. So ideally the weight of the tool should be 2.3 kilos if this tool will be used away from the body or above shoulder height, or 0.4 kilos for precision tools to allow good control. Tools that has weights above these recommended weights should be supported with a counterbalance. And ideally, the center of gravity should be aligned with the center of gripping. Okay, here's how you're gripping this tool, and it's aligned with the center of gravity. So to allow an easy hold of the tool, whether it's in the upright position or downward position. Now, going back to the Grand Chain principles, Principle 15 states that the tool should fit the body size of the user. You know that the grip or how strong we hold on to the tool while operating. So this grip um, is an important factor in the design of the tool, and this factor varies with the age of the person who's holding the tool or using it, the gender as well, how open the hand is while squeezing, and the diameter of the handle while being gripped. Principle 16 states that if the tool requires a great hand strength, so that we should design it so that we can use it by the dominant hand, meaning that if we only use our right hand to hold this tool, then design it accordingly. But it's better if we design it to be either used by both hands. And if the hand strength is very important, then we have to design the tool for individual user. Meaning that, let's consider here, for example, the scissor being used by the tailor. It's different from the scissor used for or by little children. So here the size of the opening of the scissor has an effect on how much gripping force can be exerted by the person using the tool. Okay, so because the hand strength differ greatly between children and between adults, we have to design this scissor for the specific and the individual user. That's why we should not design a tool that serves all users. We have to design the tool that serves each individual person for his purpose. Principle 18 differentiates between two types of grips. We have the power grip and we have the precision grip. Now, power grip is used, for example, to hold hammers, saws, where you have to exert a large force. So you will have to put your hand and wrap it around the handle of the tube. Wrap all of your hand around the handle of the tube. So here you're holding the tool with a power grip. You have to know that the force can be applied in different direction. You can apply the hammer upward, downward, or in any direction. You just need to understand that no matter what's the direction of the force applied, your hand is wrapped, okay, a large portion of the hand is placed in contact with the tool, okay? All of your hand is wrapped around the tool. So this allows the force to be distributed over the entire hand. While the other form of the grip is the precision grip, and here we have to differentiate also between two types. We have the internal precision and the external precision. With the internal precision, all of the tool is held within the hand. Okay, you see here, for example, the knife. All of the knife is within your hand. Okay, this involves, the grip also involves a pinch. Okay, as if you're pressing with the knife. Okay, there's a little pinch grip. Okay, and it's held within the whole of the hand. Okay, here the finger is placed in front of the tool to provide the guidance and the direction. The external precision also involves a pinch, but you can see that here, let's say whether it's a pencil or it's a tool for engraving, the tool is not entirely held in the hand. You can see that only the thumb and the two fingers are placed near the front of the tool, while the tool rests against the side of the hand. So it's not being fully held inside the hand. This is the difference between the internal and the external precision grip. So this is what's stated in Principle 18. If power is needed in a hand tool, then design it for a power grip, as for the hammers. If precision is needed, design it for a precision grip. Now, when dealing with the grip designs, there is a property that it's preferable to be found. You know that when you're holding a knife or a screwdriver, people usually apply a forward force against the object. So in this cases, the hand must be protected from slipping forward over the tool. This protection can be obtained when we enlarge the grip cross-section in front of the hand. So this is obvious when you look at these tools. You see that here this part is enlarged so that we can prevent slipping. So when the grip behind the hand is made larger, this is another desired property of grip design. Moreover, the grip material which can be used from either wood or medium hard rubber should be used to insulate the hand from vibrations. In other cases, vibration damping gloves can be used. And in general, these materials are compressible. This also helps distribute the load from the tool evenly over the hands. Moreover, the grips should also insulate from heat and electrical energy. As we mentioned, wood and hard rubber are also effective insulating material. And also the grip design should create a sense of tool orientation from the feel of the grip. Yani while we feel the tool, we can sense that this is the upward direction or the lower direction of it, so that we can place our hands easily on it. And from the feel, we do not need to look at it to know how to grab it. Now, Principle 22 states that a good hand tool design provides adequate mechanical advantage in applying force. This means that forces has to be exerted with the body while it's in its natural orientation. This means that the body should be naturally positioned, because several cases of the CTD, cumulative trauma disorder, have been reported when people are forced to work with their bodies in unnatural positions. They have to maybe bend over their back in an awkward position while applying the tool. So this is not preferable in the design of any good tool. This can be seen in the design of pliers. If the pinch point is directly in front of the operator, the wrist at this case will be bent in order to use the plier. But if the handle of the pliers is already bent, then the pliers can be used while the wrist is in its natural position. No need to bend the wrist in this case. Another advantage of bending the handles of the tool is that you can improve the eye-hand coordination. You can just by laying over your hands over the tool, you can get a good grab. Also, bending the tool provides a clear line of sight to the user, as you can see here with the different tools. Bending the handle of the tool also has another advantage, because it provides more power for the human body in certain positions. Let's say, for example, a worker is hammering some nails on the roof. So he has to, this tool, if it's bended, it will provide him more power while hammering the nails. So this is also helpful to have the handle bent. You need to know that for tools that require some opening, like the pliers or scissors, that the grip strength changes greatly with the size of the opening. Now here, for the maximum strength, you have to have an opening between 65 and 85 millimeter. This is the recommendation. Also, among the other features that are required to have in the hand tool designs is the spring that we see in some of the tools, because test shows that hands exert more force in closing than in opening. So it's very useful to add a light opening spring because it saves time and effort of opening these tools. Now, monitoring the body motions while using a certain tool can be a good indicator for determining whether this hand tool is adequate or not. Because while monitoring how the body moves, is this body maintaining natural position while using the tool, then this is a good indicator. This tells that the tool is properly designed and properly used. So body positions can be a good indicator to predict potential long-term problems. So better hand tool designs reduce muscular activity, distribute them to muscle bundles in proportion to their ability to render force. And tool designs can be evaluated, moreover, by measuring the energy level exerted by the body during the use of the tool. So a better designed tool will require less human effort. This is the indicator to determine whether this tool is adequate or not. Now, regarding power tools, you all know the advantages that the power tools provide. It first saves time, it results in more consistent performance, it can reduce fatigue and injury, and it reduces the forces that people has to exert in order to perform a certain task. One of the disadvantages of power tool is that they might be heavier than the normal hand tools, and if it's an electrical equipment, then there might be the problem of tangling, and this will present a tripping hazard. Moreover, there is the hazard of electrocution. So regarding the issue of the weight of power tools, Grant Jane proposes that the weight of power tools should be supported or counterbalanced by a fixture or mounting apparatus. Usually, if you go to any facility or a manufacturing facility, you will see that there will be different types of fixtures to support the tools, and usually they would place it above the work area. You can see different screwdrivers suspended immediately above the work area with a retractable chain or cord to facilitate the grabbing of these tools without being affected by its heavy weight. Now, as for the hazards that might be included, especially at the point of operation, Principle 25 states that a guard or barrier makes it difficult for operators to contact the point of operation. So you can see that guards can be installed to machines where a metal or plastic barrier is installed to prevent operator from reaching into the tool's point of operation. Another type of guard to prevent the operator from accidentally activating the tool or machine while having his hands within the danger zone is to put a pair of switches where the operator has to press them down at the same time with his palm to activate the machine. This is another type of guard to prevent contact, the contact of hands with the point of operation. The rest of the principles also provide some guidelines to help prevent hazards that might occur at the point of operation that you just need to have general information about, such as use machine feeding mechanism that keep hands or other parts of the body out of the danger zone, deactivate the machine or provide a warning if body parts are in danger zone, and at last, provide the operator a way to deactivate the machine under emergency conditions, and warn the operator and others who may be in the danger zone of potential dangers. So that's it. Thank you for listening.